lesson is combining a few things that we've learnt in this unit, and so we're looking at surface area and volume of composite solids. Now remember, we've done composite shapes, but we haven't done them in the 3D world. So we're going to do what we did with composite shapes, and we're going to split solids into individual shapes to calculate the volume of solids and the surface area of 3D shapes. So let's go for it. Okay, so we've got this beautiful building over here, and we want to find the volume of the building. Okay, now we have the dimensions up there, and we're going to see what we have. Now, the learning goal told us that we had to split things up into two things. So I'm going to see that up here we can see that there's a cone, and down here I can see that there's a sort of cylinder. Okay, so the first thing I'm going to do is this cone here. I'm going to do the dimensions of that. Now, both of these have formulas. This is the formula for a cone is the same as a prism, which is a third times the area. Oh, that's a really bad a third. Times area times the height. Okay. Now, the area of a cone is this shape down here, which is actually a circle, which is pi r squared. So volume of cone is equal to a third. Now the area is going to be pi r squared times the height. Now this is the height of only the cone, and in this case it is this guy here, because see how that's perpendicular height, so it'll be 2. Alright. Now what's the radius of this? Well, we know that we have, that looks like a diameter, so it looks like the radius will be 1.5, which is half of 3. So we're going to go a third pi, which is just a number. We're going to go 1.5 as our radius, because it's half of this 3 meters, times 2. Okay, now it's just calculator work, so I'm going to put this in my calculator. So a third times pi times 1.5. Make sure you put it in brackets, squared, not times 2, and then times 2 is the height of the cone. And I've got this. Now I'm going to write all this number out. All right, I'm not going to approximate to 2 decimal places like I've been doing. I'm just going to let it be. Okay. And I'm going to move these guys over there. All right. So that's the volume of the cone, and I'm going to put a line down here. Now I need to find the volume of the cylinder. So the rest of this shape down here, which is a cylinder. Okay. So volume of a cylinder, it's actually the same as a prism, and it's area times height. The height of this cylinder is 15 meters. All right, so that's pretty straightforward. But what area is it? So normally it's the area of the cross section. All right, so the cross section is this bit up here. So it's actually the same shape, which makes sense because they're built on top of each other, as this area, which is pi r squared. So I'm going to write that all into one thing. Pi r squared times h. Now I'm going to substitute. Now the radius of this one's exactly the same as the radius of this one. So we're going to use that 1.5, which is half that 3 meters over here. I'm looking at over there. All right, let's have a go. So pi times, use our brackets, 1.5 squared plus, not plus, times h, which is 15 of the cylinder. And now it's just simply calculator work. So we're going to go pi times 1.5 squared times 15, and we get, and I'm going to write the whole number as well. I'm not going to, so that's what I get there. Now the whole volume is going to be the addition of these two things. It'll be the addition of this cylinder plus this cone, because see how this shape is a cylinder and a cone? All right, hopefully you can see that I'm highlighting this building over there. So volume will be volume of cone plus volume of cylinder. All right, and we've got them both, so I'm just going to add that to that. So I'm going to write it fully out. Now the reason I haven't put it to 2 decimal places is that when we add these up, if we've rounded to 2 decimal places, it will give us slightly wrong answer. We want the right answer. So I've actually got this number still in my calculator, so I'm just going to go plus and go on to add this number here. So 4.71238898. Now I know that I've got a pretty accurate picture, so I'm going to press equals. So the total volume will be 110.741141. Now I will want to do it to 2 decimal places because it's too long. So I'm looking at this here, and it looks like it will stay the same. So therefore, the volume will be 110.74. Now units are meters, and it is volume, so I'm going to put cubed. So just remember that the volume will create this cubed. So that's it there. So essentially what I've done is I've done it to 2 different parts and then did it together. All right, we're going to do the surface area of this building as well, but it's 2 different things and it's slightly trickier. If we look at the cone first, I'm looking at this side first, all right, you'll see that we want to look at the surface area, but we're going to look at the outside of this building, okay, which means it won't include the bottom bit here because the only part of the cone is the outside bit. So if I can, I'll use it. So only the top bit, all right, so we're not seeing the bottom of the cone. The bottom of the cone is hollow because it goes straight down, okay? So this is where my understanding of the formula of the cone really pays out. I've recognized that this is the same as the area of a circle, and it actually is. So it's actually this part of the formula. Now, I don't need that anymore, okay? So the only thing I'm going to do for the surface area of the cone is do this part here, all right? Now, can I repeat myself again? This part of the formula refers to the circle in there. Now, there is no circle in here because it goes straight into the cylinder below, okay? So, let me do that. Then we're going to go pi times, our radius is the same, 1.5, and our L, remember the L in this case, is the leaning bit, all right? So the L is this leaning bit, and it actually happens to be 2.5. And there's a reason why it's there. We never used it in this example with the volume, but we'll need to use it here. So I'm going to pop that in my calculator, that calculation. And I'm going to write it all out as well because we're going to have a similar scenario to what we had with the volume of a cylinder. Okay, so that's that part done. All right, now I'm going to look at the cylinder. Now, cylinder, we have the same sort of scenario. So if I've got my cylinder, and I'll build it up here. If I've got my cylinder here, let's go there. There's our cylinder. This is the formula for a closed cylinder that has a lid and it has a bottom, okay? Now, when I look at the surface area of this building, I don't need to know the bottom because it's covered by dirt, all right? So essentially we're looking at what the surface area is like. If we were to paint this whole building, what would we need? What area would we need? And we don't need the bottom, and we certainly don't need the top either, okay? Now remember, we looked at this formula and we go, what part is it? And it actually happens to be the same part. The area of a circle formula is that there, and because there's two of them, so that's two of them here, we're only going to be using this part of the formula. Okay. If you don't get what I'm doing, please go back to surface area of cylinder lesson, because it explains this in further detail. So we go 2 times pi times our radius is the same, 1.5, and our height is this height here, which is 15. Okay? And so we're just going to pop that in our calculator. And we get this number here. I'm not going to round it off. All right, now the surface area of this building, so surface area, so I'm going to go total. I'm going to put a line down here just to show that it's different. So total surface area will equal this surface area plus this surface area. So I'm going to call this area 1 and this area 2. So I'm going to go area 1 plus area 2, and it equals, I'm just going to write it all out because I don't want to lose marks because I haven't approximated properly. The only time we approximate is when we get to the final answer. Okay, and I'm just going to add them together. Hopefully I do this properly. Make sure you're careful with this bit, and I get 282.7433388. Now, that means that I can approximate it to 2 decimal places because that's what I like to do. Therefore, surface area is equal to 282. Now, let's look at it. We're looking over here, so that means that's going to stay the same. So 0.74, our units are meters, they're meters, and it is area, which is square area, so that means it's squared. Okay, so hopefully that makes sense. If this is a little bit tricky, go back to surface area videos or lessons, because they will explain this in further detail, but hopefully it makes total sense. Peace out.